All right. So what I want to do here is move on to working with adding, subtracting radicals. Now that we know how, we have a basic understanding, I think, of how to simplify them. We can work into the other operations that ultimately are going to require simplification as we work through them. So I'm going to be asking us to add, subtract, multiply, and divide radicals. And once we do those things, or maybe sometimes you're going to see here in examples, in order to do those things, we need to first simplify, or maybe simplify at the end. So today, all I want to do is talk about adding, subtracting radicals. A lot of the work that we do will just be the examples will be adding, because subtract, if you can add them, you should be able to subtract them. It says in order to add and subtract radicals, we need to realize that radical portion is a symbol for another number. And generally speaking, because we don't usually do mental math or think in regards to irrational numbers, we usually don't know what that number is, okay, until we let software calculate it for us. So we can kind of view maybe the radicals as variables, unknown things, okay. So this being said, we can interact with the radical as we would variables like x and y and treat it like an unknown value. What I mean by that is like this radical 5 right here. Okay, we've talked about that being a symbol for another number, but we don't know what that other number is. It's a little bit bigger than 2 because radical 4 is 2 and 5 is a little bit bigger than 4, but we don't know exactly what it is. So let's consider that an unknown. Okay, maybe kind of like x. Okay, because x right here is unknown. Same thing, so I got 3 radical 5 plus 8 radical 5. That's kind of the situation I'm asking us to be able to do. Well, 5 is unknown, so I call 5x. Radical 5 is also unknown, and I already called radical 5 x once, so let's call this radical 5 also x. And we get something like this. We get 3x plus 8x. But we know that we can combine those as like terms because we talked about how we can factor out an x. So I take an x out of there, and I take an x out of there. And we'll put it here at the end. We'd be left with 3 plus 8. And we combine those like terms and get 11. Then we take 11 and multiply it by the x. And you guys we've learned that, okay, they're like variables, they're like terms. They both have an x to the first, so we just add the coefficients. But the logic of that is because of this distributive or factoring process that will allow us to group the real terms, okay, the real numbers. So the same thing can happen here. Like I said, we don't know what radical 5 is, so let's treat it like a variable. So 3 radical 5 plus 8 radical 5, that's like 3x plus 8x. Well, 3x plus 8x was 11x, so 3 radical 5 plus 8 radical 5 must be 11 radical 5. Okay? So what I'm going to try to get you to realize here and try to emphasize with you is when adding radicals, we're going to treat them a little bit like variables. Okay? And we can only add or subtract like variables, or in this case, we're going to talk about them as being like radicals. So for instance, if I gave you 3x plus 5y, you guys know, based off of what we talked about all year long so far, you can't combine those. Those are unlike terms. Okay? So that's like saying 3 radical 2 plus 5 radical 6. Because the radical 2 and the radical 6 are not like radicals, you can't combine these. You would leave that as 3 radical 2 plus 5 radical 6. Doesn't get any simpler than that. Much like you would leave that as 3x plus 5y. Okay? So some examples of this. You know this 3 radical 2 plus 2 radical 3. Is that radical the same as that radical? No, they are not. So because they are not the same, you cannot add these together and make a simpler format. So we just leave this as 3 radical 2 plus 2 radical 3. That is the most simplified way we can write that expression. Okay. Now this one here, this one's a little bit different. I'm going to write it this way. I'm going to say, I don't see a number out here in front of this second radical. So if I don't see that number, it's an understood 1. So basically, again, if this radical 5 and that radical 5 are the same, so let's say that they're like x's, I'd have 4x minus 1x. If I had 4x minus 1x, that'd give me 3x, right? So here I got 4 radical 5 minus 1 radical 5. That must give me, do the subtraction with the numbers out front, must give me 3 radical 5. Okay. Remember what, think about it this way. 4 radical 5, what that means is it's 4 times radical 5. So you have radical 5 plus radical 5 plus radical 5 plus radical 5. That's what 4 radical 5 means. And then minus radical 5. That's what that means. Well, maybe those are opposites, so they cancel each other out. How many radical 5s do you have left over? You have 3 radical 5s left over. So we're going to rewrite that as 3 times radical 5. Repetitive addition can be rewritten as multiplication. Here, again, we get like terms because the like radicals, so they're both radical 11. So then we can take the numbers out front and do the work that is indicated. So it says 10 plus 24. We get 34 radical 11. If you have a question whether you're doing the addition or subtraction right, you could type that into Desmos, your TI-83, 84, whatever it may be. Hit enter. Then type this into the next line. Hit enter. And if they are equivalent formats, then the decimals that the calculator generates should be the same. So this being said, the only time we can truly recognize like radicals is if every initial radical is fully simplified, which is what we've been doing the last couple days. So the following example exemplifies this. Notice initially that the radicals are not the same, so one might think that they cannot be combined. However, once both are simplified, you realize that they do have like radicals, and you can add them or do any other maybe subtraction that you might need to do. So we look at this, and we might see, oh, well, this is, I'm going to put a 1 out here, so 1 radical 8 and 3 radical 2. And you might look at that and say, oh, well, he just said that if the radicals are different, this is a situation where it's like, radical 8 might be x and radical 2 might be y, and I can't combine those. So I don't. I leave it as radical 8 plus 3 radical 2. However, we see that radical 8 is not simplified. Okay, that's what you always got to think about. Okay, are these radicands in all the problems that we've gone through, are they simplified? So radical 8, we can break that down to 4 and 2, and the 4 breaks down to 2 and 2. So there's a group of 2's that when I take this radical 8, they can come out in front. That 2 doesn't have a partner, so it goes underneath. So radical 8 is the same thing as 2 radical 2. And then I've got the plus 3 radical 2. Now my hope is that you can see that now the radicals are the same. So because the radicals are the same, now you can do the addition with the numbers out front. So now we get 5, 2 plus 3 is 5, radical 2, 5 radical 2's. So the idea here, and we have to do that up here because 2 and 3 are already prime, 5 is prime, 11 is prime. These examples up here, 5 was prime. So if you've got a composite number underneath the radical, you've got to make sure that it's fully simplified before you start adding or subtracting the radicals. So I got some just blank boxes here with examples. I've got another PDF here that I'm going to pull my examples off of. And actually, we'll just run through this instead of doing them in the box. We'll just run through here. All right, so if we look at this, okay, the one thing about simplifying radical, so that's composite, but the 6 breaks down to 2 and 3. So they don't have partners, so they go back up into the 6. So because the radicands are the same, so this would be like 3x minus 4x. So we can go 3 minus 4 gives me negative 1. And then the radical 6 goes along. Over here, same idea. So the radical 7's are the same thing. So now I can just do the work with the numbers out front. -3 plus 4. So it gives me 1. And then the radical 7. Let's see here. -11 radical 21 minus 11 radical 21. So again, the 21s. 21 goes down to 3 and 7. And to be honest with you, if they're not, so let's say that I had like -11 radical 20 minus 11 radical 20. That's not simplified. Neither is that. But because they're the same, right off the bat, I don't really need to simplify them. I could do that. But no program or test will we want to write that way because radical 20 isn't simplified. So as we're going through this, if your radicals are identical but not simplified, you can still do the addition or subtraction of the numbers out front. However, 21 is fully simplified already. So -11 minus 11 is -22, and then radical 21. 15 is 3 times 5, so that's simplified. So we got -9 plus 10. That's going to be 1, and I've got radical 15. So my hopes are you can see that those are the rest of these on this first page here are kind of like that. Let's go down to this one right here, number 8. Okay, so initially I might think, oh, those two things are not like terms, so I can't add them together. But the 27 can be broken down to 9 times 3, and then 9 can go to 3 times 3. So when I'm writing this 3 radical 27, so this radical 27 can be written, there's a group of 3s, so it comes out in front. That 3 doesn't have a partner, so this radical right there can change to 3 radical 3. So I'm going to change this object right there to 3 radical 3. There's already this 3 out in front. So this is going to be -2 radical 3, plus then this turns into 9, because you have 3 of these, and that radical 27 is that. So you got 3 of these, so that's why it turns into 9 radical 3. And now we can see that the radicals are the same, so do the work with the numbers out front. -2 plus 9 is 7. So 7 radical 3. If you're to go to Desmos or your calculator, whatever you're going to use, type that number in, hit plus, type that number in, hit enter, it gives you a decimal. Take that decimal, record it, and then type this blue number in, look at that decimal. That decimal should be the same as the one you recorded. Let's do number 9. Same concept here. That radical is simplified. This one, however, is not. So I take radical 24. That goes to 2 and 12. 12 goes to 2 and 6. 6 goes to 2 and 3. So I can have a group of 2's come out of my radical. And this 2 and 3 don't have a partner, so they go underneath. So this right here, that radical 24, turns into 2 radical 6. We still have that 2 out front. And it's getting multiplied together by the radical 24, which we said was the same as 2 radical 6. And then we have 2 radical 6 minus that. So this turns into 4 radical 6's. This is 2 radical 6. So 2 radical 6's minus 4 radical 6's is -2 radical 6's. Once you have the like radicals, just do the subtraction with the numbers out front. Let's do this one. So we got 54. So radical 54, that goes to 2 and 27. 27 goes to 3 and 9. 9 goes to 3 and 3. So there's a pair of 3's. Come out front. that 2 and that 3 don't have a partner, so they go underneath. So you have 2 radical 6's plus the 3, but now this radical 54 turns into that. So I've got 2 radical 6's plus now this is 9 radical 6's. So 11 radical 6. So that thing right there changes to 11 radical 6. See if there's anything kind of more complex. These are all about the same. You might see in this one here we've got 3, so we can do as many of these as we want. So radical 18. Let's come to the side here. Radical 18 breaks down to 2 and 9. 9 goes to 3 and 3. So there's a pair of 3's. So this 3 stays out, so negative 3. But now this radical 18, the 3 comes out in front of the radical, and that 2 stays on the inside. So that's what that thing turns into. Plus then this 3, but now look at radical 8. Radical 8 goes to 2 and 4, and 2 and 2. So there's a group of 2's. So this radical 8 turns into 2 radical 2. So I have a 3 that's already out there, and now a 2 radical 2. Okay, so that term is the same as this one. And now minus radical 24, well 24, we already did this earlier, but we go 6 and 4, 2 and 2, 3 and 2. There's a group of 2's, so it's going to be minus, that group of 2's can come out. And now here we've got a group of 3 and 2, so those come back underneath as a 6. So now, just to kind of simplify, negative 3 times 3 is negative 9, so I've got negative 9 radical 2's. Here I got plus 3 times 2, so 6 radical 2's. And then minus 2 radical 6's. So this is a situation, kind of go back to variables a little bit. If we look at the radical 2 here and the radical 2 there, those are like things. So we're looking at something here that's like negative 9x plus 6x minus 2, but this radical 6 here is different than these radical 2's, so maybe that's like a y. Well, if I had that, the only thing you guys could combine would be those two things there. So likewise, the only thing we combine is those two things there. So negative 9 plus 6, negative 9 plus 6 is negative 3 radical 2's. And then minus 2 radical 6, because I can't combine those, so I just write the subtraction. So that is how we add and subtract radicals. I will, just for maybe practice, I will, obviously there's a lot more questions here, and I believe, yeah, I've got the key here. If you want to run through any of these and practice them, by all means you can do that. I think that would actually be of great benefit for you. You can see here the one we just did. We did it right. So I'll post this PDF with the notes for this section on Schoology. And there will be a homework assignment that attaches to this as well in Math Excel. If you have any questions, please reach out.